Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is find the original typed string part 1. Now the part 1 of the problem is marked as easy on Leetcode, and I would say it's actually a very easy problem to solve. And after watching this video, after understanding the problem and the solution approach, you are going to find it easy. Now the input given in the problem is a word, and that word is of type string, and that's the only one input we have in the problem. The output we need to give is the total number of possible original strings you can make using the given input word. Now let us try to understand about the problem more using the task. So the thing is, in the problem it is saying that there is a person Alice, and this person is trying to type a word, and that's the input you are receiving. But when she is doing the typing, she might do a mistake, and let me tell you what. So basically when a character is typed using a keyboard, it could be long pressed and could be typed multiple times. That is, let us say you are trying to type a character A, and if you long press this character A, then you are actually typing A multiple times, right? So that is what's happening in the problem. Basically the person Alice is trying to type a word, and for this word she need to type a lot of characters, right? And when a character is being typed using the keyboard, it is possible that it could be long pressed and could be typed multiple times. You are given the word which Alice has typed. You need to find the total number of possible original strings which Alice was actually trying to type. And when I say actually trying to type, I mean what's the actual word which Alice was trying if she would have not made any mistake like long pressing. So there are multiple possibilities of that original word or original strings, and you need to find the total number of possibilities. Now the thing is, the question says that Alice is trying to be a little bit smart. So maybe this mistake can happen, but this mistake can happen at most once. That is, she might have long pressed a particular character, but this long press would have happened at most once and not more than once. The possibility is she has not long pressed any character and the given word is actually the right word. That is because this error or this mistake can happen at most once. At most once means maybe the mistake has not happened, and if the mistake has happened, it would have happened just for one character. Now we need to find the output for the given typed word which is given in the input, and the output we need to give is the total number of possibilities or the total number of possible original strings which Alice was trying to type. Now let us try to understand the question more using some examples. So in the example number 1, the given word which Alice has typed is A, B, B, C, 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 C. Now we know that Alice could have made some mistake. She might have pressed a particular character for long, and this could have typed that particular character more than once or more than the required number of times. Now this is the input, right? For this we got the output as 5. 5 means that there are 5 number of possibilities, 5 number of actual word which are possible which actually Alice was trying to type, but by mistake maybe she could have typed this particular word, but there are 5 different words which are possible which Alice was actually trying to type. So what can happen is, if this is the word Alice has actually typed, but maybe she was actually trying to type this particular word A, B, C, 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 C. Now why I can say this is one of the possibility, that's because I know that Alice could have pressed a particular character for long, but this mistake can happen at most once. Now let us say this mistake has happened, and this mistake actually happened for this character B, B. She was trying to type B, but since she pressed the button B in the keyboard, we have a button B, right, or the character B. She has pressed this button for long, and this typed it as BB, but she was trying to type B. So I would say instead of BB, it should be B. So we have A, B, C, 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 C. That's one possibility. Now, since the mistake can happen at most one, and if I am saying that this mistake has happened for this particular character BB, so even though I can see we have 4 number of continuous C, this particular continuous C is actually correct. That's because the mistake can happen only once, or I would say at most once. And if the mistake has happened with this particular character, then this is correct, right? So that is why we have A, then we have BB replaced with B, and we have C, 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 C. That's the first possibility we have. Now talking about the second one, we have one more possibility. The possibility is she was trying to type A, B, B, C. So it is A, B, B, C, 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 C. So the thing is, maybe when she was trying to type the character C, she was actually trying to type this C, but she pressed the character C long. She long pressed this character, and by mistake it typed it as C, 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 C. So that's one more possibility, right? So that is our second possibility. This is also possible, A, B, B, C, C. Maybe she was trying to type A, B, B, C, C, but when she pressed this last C, she long pressed this and it typed it 3 times. That is, A is fine, B is fine, this B is fine, this C is fine. But when she was trying to type this C, she long pressed this character and it typed the character C 3 times. So that is why this is one more possibility. Now another possibility is A, B, B, C, C, and now she was trying to type C, but she long pressed it and it typed it as CC. That's another possibility. Or maybe she was actually trying to type A, B, B, C, 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 and that's the original string given in the input as well. And I would say that's the original input and not the original string, I would say. So let's make it as original input. That's the input we have received, and maybe she has not done the mistake, because we know that the mistake can happen at most once. So maybe she has not done the mistake and that's the actual string, that's the actual input. That's one more possibility, right? That's a possibility that this could be the original word which she was trying to type. So I would say we have a total number of 1, 2, 3, 4, 5. 5 possibilities, right? And that's the output we have. Now you may try to find another possibilities from this, but it is not possible. These are all the 5 possibilities we have. Now one of the mistake you can do is maybe you try to say, okay, B, B, C, 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 C. That's one possibility, but no. You cannot remove this A and you can say that this is the string she was trying to type. See, the thing is, the question says that the mistake which is happening is while typing a character, she is long pressing it. So when you have the keyboard and when she was trying to type this character A, she would have pressed this character and it is typed once, right? We have one number of A here. We do not have any repetitions of A. We have just one A. It means this A was actually intended to be typed. This A is correct. This A cannot be the result of being long typed. That's because it is just once. And if it is just once, we know that this would have been typed. This would have been intended to be typed by Alice. Now let us see another input in which the given string which Alice has typed is A, B, C, D. In this case, there is just one possibility of the actual word which Alice was trying to type, and that possibility is A, B, C, D. That's the original input we have, right? And how can I say this? See, the thing is, I don't see any repeating characters in this particular string. We have A, then B, then C, then D. We have a keyboard. We have a here, a B here, C here, and a D here. Alice pressed the character A, then B, then C, then D. There is no long pressing of any character, and that is why there is no repetitions. And that is why I can say there's no mistake, and that's the only possibility, that's the only original string which Alice was trying to type. So one possibility. For this given string, if this is the string which Alice typed, that is A, then in this case what can happen is the output is 4. It means we have 4 different possibilities of strings which Alice was trying to type. Maybe she was trying to type just one character A and she long pressed it and got the string as A. Or maybe she was trying to type the first character A and just one more character A, but while typing this A, she long pressed it and typed it 3 times. That's another possibility. Or maybe 2 number of A's are fine, but this A is telling me that maybe she long pressed this and it typed it 2 times. So that is why this is another possibility, 3 number of A's. And maybe she has not done any mistake and that's the original input we have. So I would say that's the original input and that's another possibility. So we have 4 different strings, 4 different data which are possible, which Alice was trying to type, but she actually typed this particular word. So the output is 4. Now the solution approach for this problem is actually very easy. You just first need to solve this problem in your mind on a pen and paper and not using any program. Let us say this is the string which Alice typed. Now if I ask you, can you find the number of possibilities or maybe the actual strings which Alice was trying to type? So you would say, okay, since the mistake can happen at most once, the mistype can happen once and that too at most. Maybe she has not done the mistake and this could be the original string. So I know that if no mistake will happen, then there will always be one possibility and that's the original input, right? Maybe she was actually trying to type this. So I would say my initial result will be 1. That's the original string we have, original input we have. So I know that the minimum answer is 1, but do you see more answers than 1? Let us see this character A. This character A is 1 time. If it is 1 time, then I am sure that this is not a mistake, right? Now I got a character as B. Okay, I got a B. This is just once. As of now, this is once. We are going to loop through our data one by one. Then we are going to find more count of B, right? Or more count of C. But for now, when we are just trying to loop through our data one by one, I got one number of A. So I got one number of A. And if it is one number of A, then I'm sure that this is not a mistake, right? Then what I see is, I see the next character as B. If the next character is B, I say that, okay, I got the character B 1 times. If I get it 1 times, then I'm sure that this is not a mistake, right? As of now, this is not a mistake. If the next character is also B, this could be a mistake because now the count of number of B we have is not 1, but it is 2. When we are at this point, we have 2 number of B's. Now, if we have 2 number of B, we know that one number of B, that is this particular B, is correct. She was actually trying to type the character B. She might have long pressed and typed more number of B's, but I know that she was at least trying to type the B once. So maybe when she has typed the B character twice, it means one of them can be a mistake. So that's one possibility I'm getting. So I can say if I have typed B 2 times, I get one more possibility. Initial result was 1, I get one more possibility. That's because I have B 2 number of times. I can remove this one character B and I can say A, B, C, 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 C is another possibility, right? So now my result is 2, right? Now again let me try to see what's the next character. Next character is C. That's not B, right? Next character is C. So I got a C and that is 1 times. But now the next character is also C. It means I got a C and that is 2 times. The next character is also C. So I got a C, that is 3 times. The next one is C. I got a C, that is 4 times. And I don't have any more character now, right? So I don't have any more character. And the last thing which I got was I got C, which is 4 times. But I know that if it is 4 times, for sure at least once Alice was trying to type it, right? But the other number of C's, we have 3 more C's, right? So there is a possibility that she was trying to type just one number of C, or 2 or 3 or 4. Now I know that this one number of C is correct. It was actually intended. But the other C's are not intended, or maybe this is a possibility that this C was not intended, or these 2 C's are not intended, or these 3 C's are not intended. So we have 3 more possibilities. If the count of C we got, if the continuous count of C we got is 4, we can say this is the whole original string. Maybe she was trying to type this particular string without this C, okay? Or maybe she was actually trying to type this particular word without these 2 C's, or maybe she was trying to type this particular word without these 3 number of C's. Now I cannot say she was trying to type this ABB because for sure one number of C's are fine. She was trying to type the character C. So from here I can say I got 3 more possibilities, right? One is fine, but the other 3 C's are maybe correct, or maybe it got mistyped, right? So I can say if I have C 4 number of times, I have 3 more possibilities. Let me add it to my result. The result is 2 as of now, plus 3, which is equal to 5, and that is the output we have for this particular data. So what we can do programmatically is we can say, okay, let me say my initial result will always be 1. That's because we have this whole original string. Now let us try to find out what are the more possibilities we have. My current character is A. I can say, okay, my current character is A. The count is 1. The next character is B. My current character was A, but the next character is B. So the count of A is 1 and 1 is fine. So our result is not going to be updated. But the next character is B. The count is 1. The next character is B. The count of B is now 2. The next character is C. When this character is C now, we can say that, okay, we got B now 2 number of times. Out of these 2 number of times, 1 is fine, but the second B was intended, or maybe it was mistyped. So there is one more possibility. Then we can say we have C 1 number of times, then C 2, then C 3 number of times, and then C 4 number of times. If we have C 4 number of times, then there are 3 more possibilities, right? So I can say the total number of possibilities are the continuous count minus 1, right? We have 1, then the total number of possibilities are 0. We have 2, then the total number of possibilities are 1. We have 4, total number of possibilities are 3. 3 plus 1 is 4. We have this original string, that's the whole complete string without any issues, and that is why the initial result is 1. So 4 more possibilities plus the initial result 1, that is equal to 5. So this is how we can find the answer, find the solution of this particular problem. Now let me get back to the code editor and let me try to show you the solution in Python. So this is the complete code we have for this particular problem in Python. We are saying that the current character we have is the first character in the string, which is word of 0. The count of the current character is 1 because we have this as the first character, and then the initial result is 1. Then let us try to loop through our data, loop through our word from the index number 1, because the index number 0 is already scanned by us and it is being stored in the current variable. Now we are checking that if my current character C is not equal to current, that is, let us say our current character is A, the next character C will be in the loop, it will be B, right? So B is not equal to A, it means we have a change in the character, right? Our current character was A, now it is B. So now let us say result is equal to result plus count minus 1, because we know that count minus 1 is going to tell me how many more possibilities can a particular continuous character can give. If A is 1 time, then the number of more possibilities it can give is 0. Next is we are saying that current is equal to C. We are updating the value of our current variable and we are saying this C character is our current and count is equal to 1. Count is reset to 1. But if the character C is not equal to the current character, then we are going to say else count plus equal to 1. It means the new character in my word is equal to the current character we are having. There is a continuous flow of the same character. That is, we say that B is there and B is 1 time. Now the next character is also B. So we can say, okay, the B count is 2. The moment we see that the next character is C, we can say result is equal to result plus count minus 1, and then the current character will be C, right? Once you come out of the loop, for the last set of characters, we have not done the counting. That's because we are only counting in our loop when there is a change in the character. For the last set of character, we are going to count it again after coming out of the loop, and then we are going to return the result. And that's the complete code we have for this particular problem. You can submit this code, and this is going to pass all the test cases. So yes, you can see the runtime is pretty good. The memory used is pretty good. So we have solved this problem in a very efficient way. So guys, I think that's it for this particular video, and I hope this video explains you the problem, the solution approach, and the thought process. That's the most important thing, the thought process behind solving this problem. And if it did, then make sure that you hit that like button, and if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel as well, and I will see you guys in the next video. Thank you for watching this video, guys.